Hi. How many people have been in this room all day? Haven't left this room? Pretty much. Yeah? Yeah. I haven't been in here. We're lucky enough to have the booth that's right through that door right there. So that's the most traffic we had was coming out this door when the session's in. All right. My name is Joe DeBunza. I work at HPR Software, and we had a last-minute change here with our customer. Could not make it. And we had to kind of switch some things up here. So they're a large financial services company, and since they're not here, we can't present on their behalf. It's a legality, you know how those financial services are. So what we've done is last minute we went and kind of scrubbed the deck from their name. And thanks to the magic of digital ink, all of your pamphlets and everything have been updated too. So if you look at them, you will not see their name there anymore. It's amazing stuff. I'm just kidding. But we did from this presentation. So originally it was going to be the customer. I was going to get out of his way. He's going to tell the story. I've worked with the customer. We'll go meet with them on Thursday. We work pretty closely together. So I do know their story, but we didn't really want this to be a pitch, so I'm really going to try to talk about their story, of which we're just a part. We're a piece of this, okay? So if you have any questions, let me know. If you don't know, and we could probably hook up a conversation if you want to talk to the people over there too later. So if there are some things you really want to dive into, they're really open about talking with folks, and they're good about user groups. So we'll talk a little bit about what HPR, then the business challenge of this financial services company, and then the architecture solution. And so kind of do the history, and then we'll take it to what the future plans are, which I think are very similar to a lot of what I hear other folks saying today. So, and I won't go too much on HPR, but HPR, why do people choose this? These are the reasons really. Complexity. We do a lot of change data capture. We can capture the real-time data from source systems. We can move it in bulk. We can do partial loads, and then we stream the data in real time. We do CDC, log-based type capture. Why do folks pick us versus some other folks? Because we scale out. So this customer too, this financial services customer, again, for those who just came in who couldn't make it here last minute, so we've had to scrub their slides and take their name out, and I'm kind of presenting on their behalf, sort of. Not really, I guess. I hope I just don't say their name wrong, mess up with that. So we do this, but we have some folks who will come from some competing products when it doesn't scale. And this is what happened in 2014, is their current solution didn't scale, and their volumes were getting bigger and bigger. And then they were looking at the future with more systems that they wanted to support in their future, and we supported those. Another one is, so we can also scale out. We can install everything on a box and do remote connections everywhere, kind of as a service model. But then when folks get to these higher volumes, even from one system or from multiple systems, we can deploy agents out on the edges and do, I guess you call edge processing. So we can do some processing there. So we might deploy something directly on an Oracle database to redo logs there. Or if it's RDS and you're wanting to pull data on-prem, you have an agent out there in the same zone, availability zone on the EC2 instance, and then we compress the data and send it nice and quickly over the network. So it scales out very nicely. Pretty easy to set this stuff out. And then one thing that we do that's kind of unique also is we do data validation. And I see a few faces in the conversation, the talk I just gave, and we talked a little bit about the data validation piece. And what's really interesting is we've now taken this to another level where we can do this with the big data, like the data lakes. So if you've got your Oracle SQL Server or MySQL, whatever database, it's got these changes on these rows, and then you have it in your data lake and it's landing in a JSON or Avro or Parquet, whatever, you've basically got like a change log, a time series of data. How do you compare that back to the source single row? How do you take all these rows, coalesce it down, hash it, and compare it back to the original row? We do that. We do that out of the box. And all this stuff is integrated. It's downloaded. It's like less than 100 megabytes. Super easy to install, set up, and supports all the platforms. So that's a real quick talk about that. We've got over a quarter of the Fortune 15 customers. We move lots and lots of data, hundreds of gigabytes in redo log per hour with some of them. And then we also do, our price point is pretty aggressive too. So we have, Teach for America. They're a nonprofit. They don't have a lot of money, but still they just came and they just did a nice, Oracle to SQL Server migration, and they're using this for some other things. So we work with everyone across the board, and we've been growing pretty quickly lately here. All right, so the background. How did we meet? With this financial services company, we started talking to them about 2013. There was already a solution in there. Didn't scale. They didn't support the wide range of platforms that we also supported, and they had plans in the future. And I'll get to that towards the end, where those plans were going, where they are now. And again, it's a lot of the architectures that you're looking at today too. So what we did with them is, it was pretty interesting. We rolled in the technology over 2 years. I mean, how many people just go all in on a technology? Like flip the switch and now you moved over. Not a lot of us. We did this over 2 years, started with the tier 3 applications, tier 2 applications, and then finally with the tier 1 applications. So we've been going with the tier 1 applications now for a couple of years, and we're getting ready to take it to the more modern architecture. So the challenge they had was a real-time analytics tool. They have a data-driven decision support insight. So their availability has to be under a minute. They really want a second or two of latency between the analytics system and the online changes that are coming. So these are basically analysts that are coming in there, doing some data, and then we have some other folks that are making decisions for investment. These people manage over $1 trillion in US dollars of assets. And I mean, that's pretty big numbers. That's almost as much as Amazon Web Services made last quarter, right? So these are big numbers as a joke. They had to do some data preparation for this. Everyone's doing some data prep, and this took them weeks, sometimes months. They're out to take this down now to hours. And then they had to do data quality. How many people are doing data quality in here? It's kind of the unsung hero. How many people know what data quality is? Okay, so you got data coming in from a bunch of different places. You kind of have to make it look the same. And we were just talking in the last session about just dates alone is just a mind-boggling thing, the way all the different systems just store dates with time zone timestamps to different ranges. And then the last one, of course, are doing analytics. So how many people here have a data lake solution you're working on today or that you're going to be implementing? Yeah? Okay. So I guess you're really looking at storage, and then you're looking at how you're going to do the analytics. And then the missing piece is really how do we get the data into there. And this is how they get their data into there. And this is what's going on today. This is the piece that's running. They have data engineers, which always have a goatee, and the business analyst, which always wears glasses, and then the trading manager. So these are the people who are moving your assets around, and they're moving hundreds of millions of dollars each person per quarter at least. So they have their online analytical apps. They're all feeding some databases. Some of them are going directly into data analytics platform. Others land a database and will stream them over there. They bring it all together. They massage it. They do the data quality. And then they have their analytics tool. And then lo and behold, you are now 10% richer. Okay? It's a trading platform. So, and that's kind of another look at how that would, if we kind of went into that black box or that gray box that was there before, you're going to stage the data. You're going to do, yeah, question?
Can you go back to the previous slide, please?
Yeah. Oh.
Yeah, so see the second bullet item. So ingesting the structured data from OLTP
Yeah.
into the Hadoop. So just wondering what value it brings the Hadoop brings in if you're ingesting the structured data from outside, whereas the traditional RDB vendor like Oracle SQL are really good at it.
Uh-huh.
So what is the value add? What is the value add on Hadoop when you're ingesting structured data?
You're assuming it's Hadoop.
Yeah, let's say like Hadoop.
Okay.
Yeah, let's say so.
Well, these are actually today are Oracle databases, But your question is going to be very relevant to what's coming up next. But to answer you directly, what we typically see with a lot of customers is that you're having this data land from multiple locations, and then you need to do some sort of either metadata, some sort of data quality on it, because it's not in a state where the analytics tool is smart enough to go and like, oh, you're from here, you're from here, you're from here. It needs things kind of homogenized to some degree. And then it can start doing its magic on there. But that's really what that whole, regardless of if it's a Hadoop or an Oracle, to kind of have that raw data on there. And so there's a single landing zone, kind of a single stop, and then everyone can kind of start doing their massaging of it. And that's what would be these next few. So kind of have the staging layer, and that takes the raw, and then this foundation layer, I guess, is where you could call that massaging. I'm going to look for Unicode characters that might be coming from a UTF system and try to bring them in bounds, or I might take my date that was not fitting into we talked earlier about Avro and Epochs and all these weird things that can go on with your data, and you want to try to pull it together. And then might do some more advanced data quality things on that as well, things where they might do a customer ID or a customer name or a street address, or things that might be ST in one system and street spelled out in another system, and try to bring that all together so they know it's really the same customer, it's really the same address. Start homogenizing all that so it makes sense when the analytics tool hits it, or it makes less work for it.
Thanks. But this is typical of the Kimball model, isn't it? Like, putting the staging and going over.
Yeah, and they've been doing this for years.
Yeah, exactly.
Right, yeah. So, and this is what today, and I'll show you what they're going to next.
Okay, thanks.
Okay, sure. And then do the aggregates. So with HPR, they were doing this change data capture out of the OLT databases, replicating, make sure the data was coming over correctly, doing the data validation, make sure the data was really coming over right, that the data wasn't getting mistranslated somehow because of weird database settings. And then they looked at the application integration. So these are some of the things where they're looking at the storage that they were considering with all of this, that they're looking at, again, SQL databases, they're looking at S3, they're looking at S3 with Redshift on it, they're looking at Athena on top of the S3 stuff, they looked at Spectrum on there, they looked at HDFS with Hive, they were just looking at everything. And that's when they were planning this stuff out in 2014, some of the stuff didn't exist. Some of it might not exist by the time I'm talking. But there's probably a few things that will be invented by the time I'm done talking. But they were looking at something that could really handle all of this. And their solution wasn't that quick to adapt. So they wanted something that was super fast today, something that could validate the data, and then something that was going to grow with them. Data federation is all the data, and that's another question they had. So we're going through here, and we're going down the left side. So you do the injection, data storage, data federation, security, and enterprise governance. So the storage, now the data federation, is all the data into a single repository. Does that make sense? Should we put it all in one spot? How many people are storing all their data into one central location? Or how many people are doing like a federated? They're kind of doing this join, a Docomo type thing. Yeah. So that's a big conversation right in and of itself. So they've landed all the data, chosen to land all in one location, and then they expose everything through services. And then that way people don't have to worry about getting the data, where to go find the data. How many people know where to go find all their data? That's a big problem. You do? Oh, so we need to talk to you. But that's expose it all through the API, browse through the API, know it's there, know how fresh the data is, know what data is in there. And then they do a lot of computations on the fly. They do a lot of analytics on the fly. Security, everyone's always talking about security. It seems to come last a lot of times, hopefully not. But then who has access to it? Who has accessed it? Their analytical tool. All right, so now they're looking at this and they say, imagine a day when, everybody can trust the system. How many people have complete trust in their systems today? Yeah, everyone? That's great. That's great. Who knows where data? We have one person here who knows where the data is. Where's the data? Like the old commercial. They have some kind of transparency of into the data quality. They can know, a little bit of auditing who's gone ahead and accessed it, who's using the second data point in there. So, and how's it being used? And that's really, I think, probably one of the hardest ones in there, is we put all this data in there, you expose it through services, how do you know how it's being used? And that gets kind of tricky too. So that's some sort of form of auditing with what are people doing it, and then just going out and talking to your users. All right, so looking ahead. So this is what I'll be going and we're working on right now, and we'll go and hash some things out later this week, but they're pretty far down the road with implementing this. So it's no longer the Oracle database in there, but what they have is they're moving everything to, they still have everything on-prem. They still want to keep that very controlled. Financial services tend to do that, but they're going to start putting some pieces of this up in the cloud. So S3 was where they've decided that they're going to land all of their data. Now it's either going to go there directly through Kafka, or it's going to go through HPR and then streamed into Kafka. It depends. So they have some microservices set up with the apps. So they're switching over to microservices architecture at the same time. That's going to be talking to Kafka, so the different microservices know what's going on with each other by speaking through a Kafka, being consumers for each other's. Sending the more traditional pieces through the database, where that's getting picked up in real time. The latency requirements are constantly going down. That was a concern. Hey, I've got this stuff on premise, and it was just going on premises. Now I'm going to the cloud. Are you going to be able to keep up? And that's why we were able to now architect out this architecture where we could now put an agent up in the cloud and put it in the same availability zone, and then we could press the data down, secure it over the network, and get it to them very quickly, and then they can send it in directly into the Kafka platform. So they'll have visibility into Amazon S3, do a lot of KMS encryption in there, lock everything down, secure it. We are doing things with them such as we have manifest files that we'll create. So when we put something in S3, we don't just throw the data in there into, I might be using JSON, I forget. But we also put some metadata about that too. So for every time we write stuff up there, we put a little, hey, this is these files we just wrote. This is the tables that are in there. These are some counts, some basic stuff in there, so they don't have to go traverse everything, again, if they want to look for that data. So they're making use of some of those manifest files to help optimize some of the Amazon S queries too. So why would people have things going in S3 and Kafka? Is anyone else doing that? Is anyone doing, I guess you call that Lambda architecture? You want to put out another phrase? Is anyone doing anything like that? Is anyone going to a streaming engine and landing it on disk? Yeah? What are you doing with that? What's your?
Mainly web logs. We're ingesting through Kafka web logs into our big data platform.
Yeah, so you're doing web logs into your Kafka platform, and then you have something else going on to like a HDFS. And what's going on in HDFS?
We're sending them into Solar indexes and then using Cloudera search to display dashboards.
Okay, great. So displaying them through Cloudera and doing some dashboards from Solar. So, and when you say Solar indexes, what do you mean by that? I'm just curious.
Solar, you can index, you don't have to put it into a high database.
Oh, okay. Excellent. So I'm seeing a lot of lately too is that folks, one use case will come in and they'll say, hey, we want to land this. We're seeing a lot of ADLS too lately too, that they want to land it to some sort of file system. And people think that's great, but I need to kind of accumulate a little bit of data before I can process it in this system. So we say, okay, fine, we'll go ahead and we can do that. We can say only save up every minute and write this, or every 5 minutes, or every 10 minutes, or something like that, or save up this many bytes and then go ahead and write it in there. And then someone else comes from another group comes in and says, hey, wait a second, what happened to my real-time data? I need this within seconds. I can't have you saving this up for once a minute. And so we'll get these two competing views for people. Some people need it real time. Some people need it to be stacked up a little bit because of the Hadoop type systems, analytics. They need to munch on bigger sets of data. So we'll do things like this with them also. And they have a little bit of that, but they have a bit of also they have some different analytics that are running through Kafka that are running through S3. And then in the end, they're running into an in-memory, well, they're still working that part out, but it's a compute engine that's going to take all that data once it's all nicely massaged. And that's where they're going to do their heavy analytics, do that in compute engine. So, any questions on that? I wish they were up here talking, because I guess you guys would just be busting with questions. You say, why did you make this decision and why did you do that? But if anyone does want to talk to them, and they're a very large financial services company, we can put you in touch with them. They were very apologetic that they couldn't show up, but it was matters that were out of their control. And I think that's it, folks.